Welcome back, everyone. Yesterday we talked about identifying three-dimensional shapes and their cross-sections. Today we are going to find lateral areas of those three-dimensional shapes. Some vocabulary that you need to know is the word altitude. This is the perpendicular segment that joins the planes of the bases. For example, this would be the altitude on this oblique or slanted prism, and any lateral edge would be the altitude on a right prism. The altitude is just a different word for the height of the prism. The lateral area is what we're going to be finding today. This is the sum of all the areas of all the lateral faces. The lateral faces are the faces that are not bases. So this may be important. For example, if you are trying to cover a soup can with a label, you would not be covering the bases, the top and bottom of the soup can, with paper. Therefore, you would only be covering the lateral face and not the bases. So that's an example of where lateral area may be used. First, let's talk about the lateral area of a right prism. So excluding the bases, we would only be talking about these lateral faces. We could take it and unfold it to look at the area of the entire lateral face. So this is the area we're trying to find. Rather than finding the area of each face separately and adding them all together like this, we would take the area of the base. So the base would be, if you added A, B, and C all together, times the height. So the area would be A, B, and C all together times the height. A plus B plus C is another way to find the perimeter of the base. So to make this more simple, we would say that the lateral area is equal to the perimeter of the base times the height. Let's try this out in an example. First, when you're finding the lateral area, it's important for you to recognize what's the base. And we'll know that this is a prism because it has two bases that are parallel to one another. This is a right triangular prism. So we know the formula is perimeter of the base times the height. In order to find the perimeter of the base, I'll first need to find the value of x, the missing side on the base. It might help you to highlight the base. In order to find the missing side, since this is a right triangle, I can take 5 squared plus 6 squared and set it equal to x squared, the hypotenuse. And I will solve that to get 61 equals x squared, which means that the square root of 61 is the missing side. So in order to find the perimeter of that highlighted triangle, I have to add up all the sides. So I would do 6 plus 5 plus the square root of 61. And then the height is going to be this 7 here, since it is one of the edges of the lateral faces. So I would plug in 7 for the height. Now, in order to solve this, lateral area is already by itself, so I just need to plug this into my calculator, and you should get about 131.7. So the lateral area, you'll want to answer it with units. Add units on would be centimeters squared, since we're talking about an area. Now go ahead and try the practice problem on your own. Here's the correct answer. Next, let's talk about finding the lateral area of a cylinder. This goes back to the soup can example that we talked about earlier. In order to find the lateral area of a cylinder, it's really similar. You could unfold this lateral face along this lateral edge, and you would get a rectangle. We know that to find the area of a rectangle, we do base times height. The base is actually equal to the circumference of the circle. So for the circumference, you know that you could either use 2 pi r or pi times diameter, and then the height is going to be the height of the cylinder. So for a cylinder, it's really similar. Instead of perimeter of the base, since the base is a circle, you just do circumference times height instead. Let's do an example together. Looking at this figure, I see that 15 millimeters represents the diameter of this base, which is a circle, and 18 millimeters would represent the height of the cylinder. So when I go to find the lateral area, I'll do circumference times height, since it's a cylinder. The circumference I know I can find by taking pi times the diameter. I know the diameter is 15, so I'll plug in 15. Next, I have to multiply by the height, which I identified as 18. So I can get an exact answer on this one by taking 15 times 18 to get 270 and leaving the times pi separate. If you want an approximate answer, you can plug this into your calculator with multiplying by pi, and you should get 848.2300. So the lateral area is approximately 848.2, and add on the units would be millimeters squared. Now try the practice problem below. Here's the correct answer. Now let's talk about lateral area for a pyramid or a cone. An important word you need to know is the slant height. This is the height of the lateral face. So whether you're talking about the slant height on a cone or the slant height on a pyramid, it's the height of the lateral face. So it goes along the face, not through the inside like an altitude. For a pyramid, the formula is the lateral area is equal to 1/2 PL. So it's the perimeter of the base times the slant height this time. Instead of the regular height, the altitude, you have to multiply by the slant height. For a cone, it's almost the exact same formula. However, since the base of a cone is a circle, the perimeter of the base would be 2 pi r, because we know that circumference is 2 pi r. So when I plug that in for P in my formula, 1/2 PL, I get 1/2 times 2 pi r times L, and the 1/2 and the 2 cancel out. So the formula for a cone is just pi r L. Let's do an example together. This one is a cone. It says a conical slate roof. That means a cone. It has a height of 16 feet and a radius of 12 feet. We want to find the lateral area, so we know that we're going to need to know the slant height. I'll look at this right triangle here to find the slant height. I know that I can do 16 squared plus 12 squared equal to L squared to find the slant height. You might also recognize that this is a 3, 4, 5 triangle multiplied by 4. 12 is 3 times 4. 16 is 4 times 4. That means that my slant height would be 5 times 4 or 20. Either way you solve it, you should get the slant height is 20. Now let's go to our formula. We know the formula is pi r L. So I know the radius it gave me was 12, and the slant height I find is 20. I can find the exact answer on this by multiplying 12 by 20 to get 240 and writing pi on the end. Or I can find an approximate answer by multiplying pi in my calculator to get 753.98. Now to round to the nearest tenth, this will round up, and I will get 754.0. Because when I round the 9 up, it goes to a 0, which means that my 3 has to round up to a 4. And I want to include units with this, which would be feet squared. So if I'm trying to cover this roof with shingles or something like that, I would know that I would have to cover an area of 754 feet squared. I wouldn't want to cover the inside or the bottom of the cone with the roofing element. That's why lateral area would be important here. Now go ahead and try this formula on a pyramid. Try the problem below. Here's the correct answer. Hopefully you at least got the formula and you got the answer correct for lateral area. If you got that, that is awesome. Next step is to find the amount of paint that you need. We know that we would have to buy 5.85 gallons. Now we can't buy 0.85 gallons, so we'd have to round up to 6 gallons. I know that it costs $15 per every gallon, so that gives me a total cost of $90 to paint the pyramid. Finally, I'd like you to reflect on this question today. A square-based prism and a triangular-based prism are the same height. The base of the triangular prism is an equilateral triangle with an altitude equal in length to the side of the square. How do the lateral areas of the prisms compare? Now, this is a complicated question. I think that a diagram would help you a lot for this. So draw a picture, test out some different numbers, and see what you get for the lateral areas, and you can answer the question. Tomorrow we will continue on with areas, but we will be talking about surface areas. So we'll talk about how do lateral areas and surface areas connect. You may have already learned surface area in the past. That's awesome. You'll have a head start, and we will talk about that tomorrow. Great job today. See you then.